Hi Hannah, sorry, in class the video camera ran out of batteries, which is rather strange because I did charge it last night, so hopefully this will work now. So I'm just going to finish the last 5 minutes of class here in the kitchen. I think it cut out right here when I had established the fact that when there is a light ray that hits the mirror, this is the mirror, and through the equal angle of incidence and angle of reflection, and it bounces off the mirror and hits my eye, but the eye refuses to see, or the brain refuses to accept the fact that light bends, so it extrapolates the image back inside the mirror. So there's the big toe. So let's see if I can change colors. I don't know how well that'll show up, but now we'll go off of the little toe. So there's a light ray that hits the mirror, and angle of incidence equals angle of reflection. So those two angles are equal. And there's one that hits my eyeball that comes off the little toe. Once again, the poor silly old brain extrapolates backwards. It's supposed to be a straight line. And the little toe turns out to be there. So I will draw it. There's a little toe, and so in between are the other toes, and the foot is looking like that. Sorry about the drawing. So turns out that is why things in the mirror, they look the same size, but they look opposite. So this looks like a right foot, and this looks like a left foot. So in class, we took a mirror and we looked at our right foot, and it looked like it was a left foot in the mirror. So if you do that, you'll see that everything is opposite in the mirror, same size. And it appears to the observer that the image is inside the mirror, which makes no sense. But it looks like when you see the surface of the mirror that inside of there is your foot, and we call that a virtual image. And I can't recall if you already saw this light ray here is called an extrapolated, the kind of ray that is made by the brain that doesn't really exist. It's called an extrapolated ray. And all virtual images are made with extrapolated rays. So there we go. All right. Let's go and look at another mirror. We're setting up for Monday where we will actually be tracing rays and objects in curved mirrors, but I only be able to lay down the foundation right now. So let's look at a curved mirror. And this one happens to be called concave. So it goes like this. If you're over here, it caves in on you. So that's called concave. And we are going to observe some light beams as they approach the mirror. Let's take all of our light beams in horizontally. So if I go in horizontally with a light beam, it will obey the law of reflection. And the way you find your angle on a curved surface is you look at a straight line called a tangent, which touches the mirror at one point, and that is right where the beam will hit it. So we're going to actually do our angles from that little tangent line. So angle of incidence, maybe like that. Angle of reflection are the same. So it comes out like that. All right, let's have another light beam, a ray come in horizontally down here. Let me get rid of that arrowhead, put it back there for directional purposes. So drawing in the tangent line at that point, it's a straight line that hits the mirror, the curved surface, in only one point. And so angle of incidence equals angle of reflection. That's a pretty big angle, so maybe this one will come off like that, so that this angle equals that. And if another horizontal ray comes in, like this, looking at the tangent, alright, it's got to have an angle of incidence and an angle of reflection that are equal. So it's got to come back at a sharp angle. Angle are equal. And I'll just put one more. The one that comes straight at the midpoint of the mirror has a vertical tangent, so it'll just come right back at you. The interesting thing, when you have a concave mirror like this, all the horizontal rays will intersect. After reflecting, they will intersect in one point, and that is called the focal point. If your drawing didn't do that, you need to alter it. So the focal point is right there. There's only one more definition that you need to know before Monday, and that is, this is a curved mirror. It has curvature, and anything that has a curvature like this is part of a circle, but we've only drawn this part. But there is a radius involved still, and we call it the radius of curvature. And to find where the radius is, when I'm talking about radius, it's not the best name that they chose. Okay, I couldn't really draw my circle very round, but imagine that I draw a perfectly round circle that includes this curvature of the mirror. The center of the circle is about right here. And we actually call that the radius, but it only marks the beginning or end of the radius. So I really call it the center of the circle, but we have to go along with optics and call it the radius. So we have 2 points identified, the focal point and the radius. And again, the radius is the center of the circle if the curvature was complete and circular. So there's a relationship between the focal point and the radius, which may not be exemplified well by my picture, but you can probably believe it. It's pretty close. It turns out that the distance from here to here, from the mirror, center of the mirror to the focal point, is and this are the same. So 2 focal points equal 1 radius. 2 times the focal length equals 1 radius. Or we could say the distance to the radius divided in half is how we could find the focus. So be aware of the relationship here between the distance from the mirror to the focal point and the distance from the mirror to the radius. This is twice this. Alright, I believe that I dropped the class off there. Sorry you missed Fruity Friday and Fat Friday. We had caramel apples and bananas for, we dipped them in warm caramel for math. And then in physics, I made a pudding type pie that was very light. It had light layers and it wasn't baked. It was chilled, and that was in honor of all those people who had to fit in their dresses, ties, and pants for tonight. So anyway, so I hope that your trip was exciting, interesting, and safe. And so I will turn it over to you now, and there's no homework in physics, so over and out. Bye.